All right, so what we have here is we're going to work on 8.2, which is angle bisector. You should be a little bit familiar with an bisector. Remember an angle bisector, here's an angle, for example, and an angle bisector would be something like this line right here that would cut this angle directly in half, making each measurement, for example, the exact same, so 40 degrees and 40 degrees. Okay, that's what you know so far about angle bisectors. So angle bisector theorem is if there's a point on the angle bisector, so let's say my angle is this way, and we have a point here, and we know that this is an angle bisector, then automatically this side must be equal to this side. So if a point is on the angle bisector, so anywhere here, so let's say it's down further here, these two sides are congruent as well. Okay, so it's equal distance on each of those sides. Let's go ahead and put this theorem into action. Find the measure of QS. So automatically, here's my angle right here, QPR, and it's being bisected by S. Now you notice they didn't tell me that it was angle bisector, but I know it's an angle bisector because we know the definition. I have a line that's cutting an angle in half, and I have these little hash marks here, or halos like I like to call them, that are congruent on each side. So I identify that as an angle bisector. Therefore, here's my points on my angle bisector, and any point on this angle bisector would be congruent sides on both sides. So the question is, what is the length of QS? Well, by the angle bisector theorem, if this side RS has to be congruent to QS, and if RS is 14.7, sorry, I'm writing with my computer kind of weird, then QS is also 14.7. And that's your answer. Now it's your turn.